Hey folks, Dennis here with Las Vegas Worm Farm and the Living Soil community. It's time for our worm topic of the week. And this week what we're talking about is how Mother Nature and us as humans can affect the biology in the soil. Yes, there are living things in the soil that we need to take care of if we want to grow happy, healthy plants. So, soil studies have shown that extreme temperature changes and drought, freezes, stuff like that will absolutely change the microbial communities inside of your soil. Other research has also shown that chemicals will also affect those communities inside of the soil, those different microorganisms. Now, the effects of the chemicals vary on the amount that is used, the soil that it's used on, the type of product that it is, the exposure period, and all these other things. But here's the crazy thing. Whenever I look at it underneath my microscope, sorry, y'all can't see that. It's right there. I can see those changes occur, right? So by the end of this, you'll be able to understand the different types of microorganisms in the soil and how what they kind of do and how we can actually maybe protect those guys a little bit more so that we can ultimately get the growth out of our plants that we're actually looking for, right? Because at the end of the day, that's what we want. We want happy, healthy plants, right? So we'll look at the weather. We'll look at some of the conditions. We'll also jump into some of the chemical or disturbances, whatever you want to call those. We'll also look at finally, we'll look at the communities that are in the soil. And then how do we make sure that that stuff, stays there where it's supposed to and alive. So weather and Mother Nature changes all the time, right? The weather changes. Mother Nature changes her mind on whether she wants it to be hot, cold, rainy, snowy, windy. She has all of the power to be able to do that. And when those things occur, the microbes in the soil respond to that, right? And this matters because some of those microbial communities will die, right? When the temperatures increase too hot, or when those temperatures get too high and it gets too hot, some of those microbes will actually die off. They don't like it. They're like, nope, no, thank you. I don't want to be here. The same thing occurs when things get too cold. They will die off, and some of them don't like to be here. Some of them are more drought tolerant than others, right? So when this stuff occurs, cycling of nutrients in the soil changes, right? So temperature increases, it gets hot, those microbes die away, and now you're left with fewer microbes to be able to create nutrients. So we have to make sure that we think about this and then make sure that we add the right microorganisms back into the soil that will continue that cycling of nutrients, right? This is why we're always talking about, seasons are changing, it's time to put more microbes in the soil to make sure that, our plants can keep going, or the new plants that we're going to put into the ground have everything that they need to be able to grow to their fullest potential. Now, that heat, right? We didn't talk about the cold, but the cold does the exact same thing. Now, that heat or that cold spell will do the exact same thing, right? When things get dry, things die. Hey, that kind of rhymes. All right. When things get dry, they die. And the same thing goes not just for your plants and us as human beings, right? Because if we don't have enough water, we're going to die. What is it? Like 3 days without water, you'll die, and 10 days without food, you're supposed to die. So the same thing goes for your plants and the microorganisms in the soil. If there's not enough water and drought conditions occur, then those microorganisms are going to die, right? Some of them won't die. Some of them will actually go into a dormant state. They will insist, right? And we can see that underneath the microscope, but a lot of those will die. Now, when they do insist, whether they're going to wake up or not is kind of, we'll see. We don't really have like a doorbell or a thing that's like, yep, you're going to wake up right now. They don't have an alarm clock or anything. So it's kind of whenever the conditions are right for them, they're going to wake up again. But when those drought conditions occur, a lot of those microorganisms die off. And that matters because we lose the nutrient cycling. We lose the nutrients that we need to grow our plants, right? So we don't want those guys going dormant. We don't want those guys dying and going away. And that's why we always talk about, keeping the soil moist, using all of your digits to figure out what the moisture in the soil actually is, right? Before we start watering. Because the last thing we want to do is, have those guys dry out and go away. The key here is to remember is to remember not to let anything dry out, right? When things dry out, microorganisms die, and we don't want that to occur, because when they die, then our plants start struggling, get stressed out, and then our plants will ultimately die. The same thing happens if the soil gets too wet, right? So we talked about the heat, the cold, if it gets too dry, if it gets too wet. Too wet is a different story, because we start running into issues where you suffocate your plant, right? Like there's plants that live in water. Don't get me wrong; those plants live in water. But if we're trying to grow fruits and veggies, the majority of those don't grow in water. They grow in the soil where they need oxygen. And if we put too much water into our soil, then we're going to flood it, and then we're going to not only kill our plant because it doesn't have enough oxygen, but some of those microorganisms in the soil will actually also die, right? We want the aerobic, the microorganisms that operate with oxygen, right? Just like our plants, they operate with oxygen. We want those soil microorganisms that operate with oxygen. And if we saturate the soil, then we start bringing anaerobic microorganisms, right? And we can see that using the microscope. There's some indicators there, different types of microorganisms that start showing up. Then they are indicate, or they're telling us that there's not enough oxygen. So we want to kind of stay away from that. Not enough, not too much, not too little, but just right. Does that sound familiar? Yeah. We want it to be right in that just right zone. Okay. So if you like this type of stuff, do me a favor, give it a like, give it a share so it reaches other people. Otherwise, keep watching the content, and hopefully there's some information that you'll enjoy here. But for now, let's get back to it. The other way that you can kind of disturb, or that things that you can do that will actually disturb the microorganisms in the soil, are adding chemicals, right? It doesn't matter if you're adding herbicides, pesticides, fungicides, anything that's an aside is going to affect the microorganisms in the soil. Now, it will depend on, right, like the duration of usage, how much you use, right? Like your soil, your conditions is very dependent. But if you use it on a consistent basis, that's usually bad, like really bad. And why this matters is because those asides, right, they're not really targeting one specific thing. While it might say that on the bottle, right, when we look at it underneath the microscope, it's actually killing a bunch of different microorganisms. So it's not really specific to one specific thing. It's actually wiping out a lot of different things in your soil. And when that occurs, guess what happens? Yes, 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 you said it. Those nutrients, the nutrient cycling that would normally occur doesn't occur because we've lost all of those microorganisms now, right? So does it kill everything? No. Does it kill it completely? No. But those effects and what actually occurs really depend on how much you use, the concentration, how often, your soil conditions, right? There's a lot of things that go into it. But what I can tell you is that it does kill the microorganisms. So we have to be careful when we use these different types of products in our garden and stuff. Usually I will tell folks that it is a last resort, right? When we have an infestation and we need to handle things very quickly so it doesn't get out of hand, maybe it's time to grab a chemical. I understand that some people don't like that, but everybody's different. There's a solution for everybody, right? But if you do grab a chemical and that is the direction that you go towards, right, remember that you are knocking back some of that biology. So we need to make sure that we bring that biology back, right? We want to make sure that we re-inoculate that area. Now, we should be doing that every time we have an event. Re-inoculation should occur every time we have a hot weather event, a cold weather event, a flash flood, whatever Mother Nature throws at us. When it's an extended period of time, right, that we're having harsh conditions, we want to make sure that the biology is still in the soil, and that's where we want to re-inoculate that, right? And make sure that those microorganisms that are cycling those nutrients for our plants, right, are there in enough numbers to keep the plant happy and healthy. Now let's talk about some of the biology that's actually in the soil. Okay. Bacteria is the most abundant thing on the face of the planet. Like, they're everywhere, right? So when people are usually reaching for different types of binocular or different types of foods to feed biology, they're a lot of the times they're reaching for things that feed bacteria, right? And I'm not a huge fan of that because while bacteria does cycle some nutrients, it is very little and it's usually not enough for the majority of the plants that we're trying to grow. If you're just trying to grow grass, feed the bacteria. You're perfectly fine doing that. But if you're trying to grow anything else, then more than likely the bacteria is not the only thing that you need to feed in the soil. Bacteria breaks down organic material. They also break down some minerals. They have like these glues or alkaline glues that they can use to break down different things in the soil, right? And they're really good at that. But that's not enough. It's not enough. So be careful what you're feeding your soil, right? We always talk about feeding the soil and making sure that there's food for everybody. We don't just want to feed the bacteria. We want to make sure that we're feeding all of the other guys that are in the soil. Now, what are those other guys that are in the soil? Well, a lot of them feed on bacteria. So we want to make sure that we have those guys because the guys that are feeding on the bacteria are the ones that are creating a lot of the nutrients for our plants. Or if you want to call them grazers, right? There's a lot of other grazers in the system that are going to create nutrients for our plants. So if we think about grazers, there's a lot of grass that grows, right? Grass all over the United States, there's a lot of it, right? And there's a lot of things that eat grass, a lot, right? And then that is kind of our grazers in the soil. There's a lot of bacteria in the world. There's a lot. And then there's a lot of grazers that are eating those bacteria. And some of those bacteria or some of those grazers are called protozoas or protozoans or protists. Now, these protists, they come in different types, right? There's all different types. There's flagellates and there's different types of flagellates. There's different types of amoebas. There's ciliates, right? There's all different types. Arcelias, naked amoebas, testate amoebas, right? Different types. All of these guys graze on the bacteria that's in your soil. Now, when they're grazing on the bacteria in your soil, they are actually releasing nutrients to your plants. That's what's actually occurring. And I believe there's somewhere between when they're feeding, they eat somewhere between 10 to 20,000 bacteria every day. Just one protozoa, just one. That's how much bacteria they actually eat. It's a lot. So therefore, they're cycling more nutrients. Because bacteria are so small, protozoas are bigger, they need more food source to be able to keep themselves fed, happy and healthy, and therefore they also release more nutrients. Now, some of these protozoans in the soil, right, they indicate different things. Like earlier, we were talking about an aerobic system with oxygen and an anaerobic system with, not enough oxygen. And when I said ciliates are one of those indicator microorganisms that will actually tell you whether you're going one way or the other, right? This is something that we look for when we're doing soil biology analysis to see where the soil is actually at, especially in the worm world, right? Because like when we have worm castings tend to be really, really heavy on the moisture. So we really have to make sure that we don't cross over from the aerobic to the anaerobic, because that could be really detrimental, not just to the microorganisms in the soil, but also our worms, right? So now that we have the protozoans that are feeding on, the bacteria, there's other critters in the soil, and these guys would be called, like, let's go up the ladder, right? Nematodes. Now, I know some of you guys are probably thinking, "Oh my God, Dennis, nematodes are terrible. We don't want them in our soil." We'll pause there. Yes, there are some, but let's break these into different categories, right? There's different types of nematodes. There's nematodes that feed on bacteria. There's nematodes that feed on fungi. There's nematodes that feed on roots. Those are the guys that you don't like. There's predatory nematodes. There's omnivore nematodes, right? There's all different types. And the root feeding nematodes that everybody talks about, usually that create the nodules, right? The root knot nematodes, they create root knots. Those are the bad guys, but that's only one group, right? That's only one group out of so many other, nematodes that are there. These guys, they have different different foods that they feed on, right? Bacteria guys feed on strictly bacteria. And if you think about it, if a protozoa is this big, then a nematode would be this big. It's a lot bigger. I think they're probably about 20 times the size, depending on the type, the species it is, and depends on the type of protozoa, right? Like if I say a testate amoeba, I could probably say that a testate amoeba, somewhere between 10 and 20 testate amoebas, is the size of like an average nematode. But now, if we're getting into the predatory ones that are really big, it's going to be way bigger than that, right? Predatory nematodes are usually twice the size of a regular nematode. So if you think about, how much food those guys need to eat and how much more nutrients that they're going to create for our plants, we want to make sure that we have all of those guys, because that's so much more nutrients that our plants can have access to, right? Now, as we move up in this ladder of microorganisms, right, then we start getting into your microarthropods. Those guys can feed on organic material, and sometimes they feed on different microorganisms in the soil. Then we get into worms, and worms, as we know, they feed on organic material, maybe. If you listen to me, they actually feed on microorganisms, right? So, but they also create more microorganisms, more nutrients for your plants. So all of these guys create this healthy soil system. And one of the guys that a lot of people talk about is also fungi, right? Fungi perform a massive role in soil, and depending on the type of plant that you're growing, you might need a lot more fungi in the soil than you do bacteria, because they perform such a vital role for your plant, right? The way I kind of like to act or talk about fungi is kind of like highways, right? In the United States, if you want to get from one location to the other, right? All of the food is grown in California. If you want to truck that stuff all the way, or if you want to get that food all the way to the East Coast, how do you do that? Usually you put it on a truck, right? And that truck is going to drive from one location to the other. And if we take that highway and that system that we just talked about, and we think about it as fungi are doing the same thing. They're transporting from one location to the other. They're just really, really long and really, really big. Quotations around that because it's microscopic, right? But they're really, really long and really, really big, can reach really far to bring nutrients from one location to the other, right? They have the ability to do that. So they play a huge role in the soil. Now, all of these guys are super important, and we have to get those guys back into the soil whenever Mother Nature does things. So right now in Las Vegas is massive. It's huge. We're supposed to have another heat wave come through. It's supposed to be like 116 this week. And the biology in the soil is absolutely going to change, because we're going from 106 to 105 to 116, right? That is a massive jump. And the same thing happens when August comes and we start getting those cooler temperatures, where we go from 110 down to the high 90s, right, at the end of the month. Hopefully. Sometimes it happens, sometimes it does. But when those temperature changes occur, we need to make sure that we get the biology back into the soil, because some of those guys are going to die. Some of those guys are going to stay, but we want to make sure that everybody's there. The way I kind of always tell this to folks is like, whenever you show up to a buffet, right? Like a buffet that has just a few things sucks. Nobody really wants to go to it. They're like, yo, they only had chicken and pork, and they only had like 3 vegetables, and they didn't have any seafood. They had no crab legs, right? They didn't have any dinner rolls. They were all sold out, and they only had a soft serve ice cream machine. That buffet sucks. Nobody wants to be there. Neither does your plant when temperature changes and all of those microorganisms go away that create the nutrients for your plant. Your plant doesn't want to be there. It's like, this buffet sucks. So unfortunately, your plant can't just get up and leave and go to a different buffet, right? So it's going to start dying. And then you get the pests and everything else that comes in to try to take care of that plant, as in like eat it and get rid of it, right? Because that's what Mother Nature does. So we want to make sure that we're restocking that buffet in the soil, right? Every time we have some type of event, you restock those microbes in the soil. You get those guys back in there, and you're like, get back in there, get back in the ring, keep going, right? Like, keep doing what you're doing. And we have to do that every time the seasons change, at a minimum. That's what I always recommend. Right before you go into your next growing season, you want to make sure you get those microbes out there. Anytime you have a massive event that's like you get a heat wave or something occurs, right? Or you get a frost and everything gets cold really fast, you want to make sure you get those microbes in there so that they can continue cycling and providing nutrients for your plants. Weather and chemicals have the same effect. If you're going to use chemicals, and you're using them not on a regular basis, I wouldn't recommend using chemicals and biology together at the same time on a regular basis. Pick one. But if you are using, or if you are growing organically, right, and you have to use chemicals and you're using them sparingly, like only when you need them, then use them. But remember that you're going to set back the biology, and you have to get that biology back in there. So make sure you use the chemicals, whatever it is. Once the problem goes away, then get your biology back in there so everything can continue cycling and your plant can be happy and healthy. You need all of those guys in the soil if you want happy, healthy plants. That's just how this works. Mother Nature gets a vote. And when she does, we can sit back and let her, veto things like, not this plant's going to die, that plant's going to die, that plant's, or when she comes in and she starts waving her, weather wand and starts making things, too hot or too cold or whatever, we can come in and say, no, thank you. We'll put the biology back out and make sure that, the nutrients continue to cycle so that our plant can uptake all of those and continue to grow to its fullest potential. But that's all I really have for you guys this week. If you have any questions, drop them down below. Thanks for watching, and we'll see y'all next week.